Welcome to helpyourmath.com. Today's problem, we're going to do problem number 4 in the final review for the MAT206.5 class. So in this problem we have, if cosine of theta equals negative radical 2 over 3, find sine of theta, tangent of theta, where theta is in the second quadrant. So the first thing we're going to do for this problem is we're going to set up the quadrants, right? And we're going to set up what we know about cosine, because we know cosine of theta equals adjacent over hypotenuse, right? And this is the adjacent side over the hypotenuse side. So again, when we're in the second quadrant, it looks like this, right? We're in this quadrant because this is 1, 2, 3, and 4. So, because we're in the second quadrant, we're going to just detail the quadrant based on what we know. And we're also going to use this triangle based on the angle. So here we know every reference angle pertains to the x-axis. So here we have our angle, theta. Here's our right angle. And we know the adjacent side here, in this case, is going to be negative radical 2 over 3. Now we know the hypotenuse is always positive, so we're just going to ignore the negative on the hypotenuse and we're going to apply it to the adjacent side because we're in the second quadrant and we know here the x is negative, while the x on the right side is positive and the y here is positive and the y here is negative. And so our adjacent side, which is this side, adjacent to the angle, because it's next to the angle, which is what adjacent means, is negative radical 2. The hypotenuse side is always the third side in every legs of the triangle. So these are the legs. This is the hypotenuse. So this is the longest side of every triangle, and this is our hypotenuse, which is the value of 3. And what we don't know in this triangle is what the opposite side is. So we're going to just leave a question mark for this opposite side. We're going to put this and say, what is the opposite side? Well, we do know a few things about triangles and the Pythagorean theorem, so we're going to use that so we can accomplish getting the sine and the tangent. Because cosine is adjacent over hypotenuse, we know sine of the angle is the opposite side over the adjacent side. While the tangent of a triangle, of a right triangle, is always the opposite over the adjacent. And once we discover these sides, these two are going to be very easy to quantify. Now we know here that the opposite side has to be positive because the y value is positive. So we know the adjacent side is the only negative side. We also know sine is positive in the second quadrant, while tangent is negative. So we'll see how that works in a little second based on what you know about trigonometry. So let's first determine what the three sides of the triangle are by using the Pythagorean theorem, which tells us a squared plus b squared equals c squared. And now using this triangle, usually what I like to do when I use this triangle is associate the a with the adjacent side. So I'll just write here adjacent squared. And the b side is usually the opposite side, which is the opposite side being squared, and the c is always the hypotenuse. And we're squaring that. Now, our adjacent side we know already to be negative radical 2. So we have negative radical 2 in here, squared, plus the opposite side, which we don't know, it's the question mark, right? So we're just going to label this side y because it's a y value, right? We're going to put a y in here. And the hypotenuse we already know to be 3. So we're going to plug in the 3 here as well. We're going to square that. So this becomes a negative b squared is always positive. The square root of 2 squared is the square root of 4, and we know the square root of 4 to be 2. So we got a 2 here, plus the value of the y value squared of the triangle equals 9. Now all we have to do is solve for the y squared. Now particularly what we want to do here is subtract 2 to both sides. And what we're going to get here is the 2's cancel. We get y squared is equivalent to 7. And when we take the square root of both sides, this could be plus or minus, but because the y is on the positive side, we know this is a positive solution. So we're going to get y is equivalent to the square root of 7. Now pay close attention to this, because if we were in the third quadrant, y would be negative, which makes a big difference to what we're going to get up here. So now that we have our value of y, since it's being positive, we just take the positive square root of 7. We can fill in everything we know, because since y is the opposite side, we know the opposite side is equivalent to the square root of 7, and it's the positive square root. So now let's fill in what we know. We know that the sine of the angle is equivalent to the opposite over adjacent. The opposite is radical 7, and the adjacent is just 3. So here's the sine of the angle in the second quadrant, which is radical 7 over 3. To solve the tangent of the angle, we take the opposite and place it over the adjacent. And again, the opposite is the same as sine's opposite, which is radical 7. And the adjacent side, again, is negative square root of 2. And this takes some solving to do because you have to usually rationalize them. Unless your professor takes your solution just like this, we have to make sure there's no square root in the denominator. Besides that, the negative is automatically going to associate with the numerator. So we're just going to put this here as negative square root of 7 over square root of 2. And these are dividing each other. So we can say this equals negative square root of 7 over 2. But before even doing this, let's just rationalize the numerator and denominator by multiplying the top and bottom by the square root of 2. This becomes the square root of 4 over the square root of 14 over the square root of 4. And this becomes a 2. And there's no square root to the of 14. So we're just going to leave negative radical 14 over 2. And this is our tangent of the angle. Thank you.